According to the National Electrical Code, all service panels must have a main disconnect or main breaker. It is not industry practice to install a breaker in the interior of a panel instead of a main breaker. A main breaker is designed to protect the entire panel and all of its circuits. A breaker installed in the interior of the panel provides protection only for the circuits below it. A main breaker is typically located at the top of the panel for easy access in an emergency. Installing a breaker in the interior makes it difficult to disconnect the entire panel in a timely manner. Installing a breaker in the interior of a panel without a main breaker violates the National Electrical Code and voids any electrical permits or inspections. Approving this field change could have serious consequences, including safety hazards, code violations, failed inspections, and potential legal liability. It is strongly recommended that you do not approve the field change and instead require the electrician to replace the 38-inch enclosure with a 50-inch enclosure and install a proper main breaker. While time constraints are understandable, it is essential to prioritize safety and code compliance. Changing out the enclosure will ensure a safe and code-compliant electrical system, which is crucial for the protection of people and property. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It's not law itself, but it's widely adopted by states and municipalities, making it effectively a legal requirement in many areas. One of the core principles of the NEC is ensuring that electrical systems are designed and installed to minimize the risk of fire and electrical shock. That's why it mandates the use of main breakers in service panels. A service panel, also known as a breaker box or electrical panel, is the central distribution point for electricity in a building. It receives power from the utility company and distributes it to various circuits throughout the structure. The main breaker is a critical component of the service panel because it acts as the primary disconnect point for the entire electrical system. It's essentially a large switch that can quickly shut off all power to the building in case of an emergency, such as a fire, flood, or electrical fault. The NEC requires that all service panels have a main disconnect, which can be either a main breaker or a fuse disconnect switch. The purpose of this requirement is to provide a readily accessible means of cutting off all power to the building, thereby protecting occupants and emergency responders from electrical hazards. Installing a breaker in the interior of the panel instead of a main breaker circumvents this critical safety feature. When a breaker is installed in the interior, it only protects the circuits downstream from that breaker. It doesn't provide overcurrent protection for the entire panel or a quick disconnect means for the entire electrical system. This can create a number of dangerous situations. For example, if there is a fault in the panel itself, such as a short circuit or ground fault, the interior breaker may not trip, leaving the panel energized and posing a significant risk of electrical shock or fire. Similarly, if there is a fire in the building, emergency responders may not be able to quickly de-energize the electrical system, putting themselves at risk. In addition to the safety concerns, installing a breaker in the interior of a panel without a main breaker also violates the NEC. This can result in failed inspections, fines, and other legal consequences. Electrical inspectors are responsible for ensuring that electrical installations comply with the NEC. If an inspector finds that the service panel doesn't have a main breaker, they will likely fail the inspection and require the homeowner or contractor to correct the violation. Furthermore, installing a non-compliant electrical system can void any electrical permits that were issued for the project. Electrical permits are required for many types of electrical work, and they are designed to ensure that the work is performed safely and in accordance with the NEC. If a permit is voided, it can create significant legal and financial problems. In some cases, installing a non-compliant electrical system can also create potential legal liability. If someone is injured or property is damaged as a result of an electrical fire or shock, the homeowner or contractor could be held liable for the damages. Therefore, it's essential to always comply with the NEC and install a main breaker in all service panels. The recommendation to replace the 38-inch enclosure with a 50-inch enclosure and install a proper main breaker is based on the need to comply with the NEC and ensure the safety of the electrical system. While time constraints are understandable, it's important to prioritize safety and code compliance. Cutting corners on electrical work can have serious consequences, so it's always best to do the job right the first time. Changing out the enclosure may seem like a time-consuming and expensive task, but it's a necessary step to ensure a safe and code-compliant electrical system. The larger enclosure will provide enough space to install a proper main breaker, which will protect the entire panel and provide a quick disconnect means for the entire electrical system. Additionally, the larger enclosure will provide more room for future expansion, which can be beneficial if the electrical needs of the building increase over time. Ultimately, the decision of whether or not to approve the field change rests, but it's important to carefully consider the potential consequences of doing so. Approving a non-compliant electrical installation can create significant safety hazards, code violations, and legal liabilities. Therefore, it's strongly recommended that you reject the field change and require the electrician to install a proper main breaker in a code-compliant enclosure. Understanding the National Electrical Code is paramount to ensuring safe and compliant electrical installations. Let's delve deeper into some specific sections relevant to service panels and main breakers. Article 230 of the NEC, titled Services, provides comprehensive requirements for service conductors and equipment. Section 230.70 specifically addresses general requirements for overcurrent protection. This section mandates that each ungrounded service conductor must have overload protection. In simpler terms, every live wire bringing power into the building must be protected by a fuse or circuit breaker. The size of this overcurrent device, typically a main breaker, must not exceed the ampacity of the service conductors. Ampacity refers to the current carrying capacity of a conductor, which is determined by its size, material, and insulation type. The NEC provides tables, such as Table 310.15b16, to help determine the appropriate ampacity for different types of conductors. For instance, if the service conductors are rated for 200 amps, the main breaker should not exceed 200 amps. The purpose of this requirement is to protect the service conductors from overheating and potentially causing a fire. Another important section is 230.71, which covers maximum number of overcurrent devices in a service. This section limits the number of overcurrent devices that can be used to protect the service conductors. The general rule is that a service must not have more than 6 overcurrent devices. However, there are exceptions to this rule, such as when using a main breaker that protects the entire service. Section 230.90, titled Service Overcurrent Protection, further elaborates on the requirements for main breakers. It specifies that the main breaker must be readily accessible and located at a point nearest to the entrance of the service conductors. This ensures that the main breaker can be quickly and easily accessed in case of an emergency. The NEC also addresses the physical installation of service panels and main breakers. Article 408, titled Switchboards, Switchgear, and Panel Boards, provides requirements for the construction, installation, and wiring of these types of equipment. Section 408.36 specifically addresses the overcurrent protection of panel boards. This section requires that panel boards be protected by overcurrent devices, such as main breakers, to prevent overloading and potential damage. The NEC also contains requirements for the labeling of service panels and main breakers. Section 408.4 requires that all circuits and overcurrent devices be clearly and legibly marked to indicate their purpose. This helps to ensure that electricians and other qualified personnel can easily identify and troubleshoot electrical problems. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It's important to check with the local building department or electrical inspector to determine the specific requirements in your area. These local codes may be more stringent than the NEC, so it's crucial to comply with all applicable regulations. Understanding the NEC and local codes is essential for ensuring that electrical installations are safe, compliant, and reliable. It's always recommended to consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. Let's consider some practical examples to further illustrate the importance of main breakers and NEC compliance. Imagine a scenario where a homeowner decides to install a new electric vehicle charger in their garage. The charger requires a dedicated 50-amp circuit, which means adding a new breaker to the service panel. If the service panel is already full, the homeowner may be tempted to simply replace an existing breaker with a double-pole 50-amp breaker. However, this could overload the service panel and create a fire hazard. The NEC requires that the service panel be properly sized to accommodate the additional load of the electric vehicle charger. This may require upgrading the service panel to a larger size or installing a subpanel to distribute the load. Furthermore, the NEC requires that the electric vehicle charger be installed by a qualified electrician and that the installation be inspected to ensure compliance with applicable codes and standards. Another example involves a commercial building with multiple tenants. Each tenant has their own electrical meter and service panel. The NEC requires that each service panel have a main breaker to protect the tenant's electrical system. This ensures that each tenant can quickly disconnect their power in case of an emergency, such as a fire or flood. The main breaker also protects the tenant's equipment from overloads and short circuits. If one tenant's electrical system experiences a fault, the main breaker will trip, preventing the fault from spreading to other tenant systems. In addition to these practical examples, it's important to consider the long-term benefits of complying with the NEC. A code-compliant electrical system is more reliable, safer, and more efficient than a non-compliant system. It's also easier to maintain and troubleshoot. Furthermore, a code-compliant electrical system can increase the value of your property. Potential buyers will be more confident in purchasing a property with a well-maintained and code-compliant electrical system. Conversely, a non-compliant electrical system can be a red flag for potential buyers and could decrease the value of your property. Therefore, it's always a good investment to ensure that your electrical system is code-compliant. In conclusion, the NEC is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. Main breakers are a critical component of service panels and are required by the NEC to protect the entire electrical system and provide a quick disconnect means for emergency situations. Complying with the NEC and local codes is essential for ensuring the safety, reliability, and efficiency of electrical installations. It's always recommended to consult with a qualified electrician to ensure that all electrical work is performed in accordance with applicable codes and standards. The electrician should be able to assess the existing electrical system, determine the appropriate size and type of main breaker, and install the breaker in a code-compliant manner. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember, electrical safety is not something to be taken lightly. It's always best to err on the side of caution and consult with a qualified professional. The consequences of a non-compliant electrical system can be severe, ranging from minor inconveniences to life-threatening hazards. Therefore, it's essential to prioritize electrical safety and ensure that all electrical work is performed by qualified professionals in accordance with applicable codes and standards. The role of overcurrent protection within a panel board is a layered defense against electrical hazards. It's not just about having a main breaker, it's about the coordinated operation of all breakers within the system. Let's consider the scenario where a branch circuit breaker fails to trip during an overcurrent event. This could be due to a malfunctioning breaker, an improperly sized breaker, or a wiring fault. In such a case, the main breaker acts as a backup, protecting the entire panel board and preventing a catastrophic failure. The main breaker is typically sized to protect the panel board's busbars, which are the conductive bars that distribute power to the branch circuits. If the total current drawn by the branch circuits exceeds the ampacity of the busbars, the main breaker will trip, preventing the busbars from overheating and potentially causing a fire. The NEC provides guidance on how to properly size the main breaker and branch circuit breakers to ensure coordinated operation. The general rule is that the main breaker should be sized to protect the panel board's busbars, while the branch circuit breakers should be sized to protect the individual circuits they serve. The NEC also requires that the breakers be properly labeled to indicate their purpose and ampacity. This helps to ensure that electricians and other qualified personnel can easily identify and troubleshoot electrical problems. In addition to the main breaker and branch circuit breakers, some panel boards may also include surge protection devices. These devices protect the electrical system from voltage surges, which can damage sensitive electronic equipment. Surge protection devices are typically installed at the main panel board and at individual branch circuits. The NEC provides requirements for the installation and wiring of surge protection devices. It's important to follow these requirements to ensure that the surge protection devices are properly installed and functioning correctly. Panel boards are also subject to environmental factors that can affect their performance. For example, humidity, temperature, and dust can all contribute to corrosion and other forms of degradation. The NEC provides requirements for the protection of panel boards from environmental factors. These requirements include using enclosures that are rated for the specific environment, providing adequate ventilation, and performing regular maintenance. Regular maintenance is essential for ensuring the long-term reliability of panel boards. Maintenance tasks include inspecting the breakers for signs of damage or corrosion, tightening the connections, and cleaning the panel board interior. It's also important to test the breakers periodically to ensure that they are functioning correctly. The NEC recommends that breakers be tested every 3 to 5 years. Testing can be performed using a variety of methods, including visual inspection, resistance testing, and trip testing. Visual inspection involves looking for signs of damage or corrosion. Resistance testing involves measuring the resistance of the breaker's contacts. Trip testing involves applying a known overcurrent to the breaker and verifying that it trips within the specified time. If a breaker fails any of these tests, it should be replaced immediately. In addition to regular maintenance, it's also important to keep the panel board area clear of obstructions. This helps to ensure that the panel board is readily accessible for maintenance and emergency situations. The NEC requires that there be at least 3 feet of clearance in front of the panel board. This clearance must be maintained at all times. By following these guidelines, you can help to ensure that your panel board is safe, reliable, and compliant with all applicable codes and standards. Remember, electrical safety is a shared responsibility. It's important to be aware of the potential hazards and to take steps to mitigate them. If you are not comfortable working with electricity, it's always best to consult with a qualified electrician.